Have you ever wondered about the power of the sun, beyond the light and warmth it provides us on a daily basis? Well, the sun is capable of much more, including the production of solar flares, which are powerful bursts of energy that can have significant impacts on Earth. Solar flares are sudden and intense bursts of radiation that come from the sun's surface, often in the vicinity of sunspots. These flares are the result of the release of magnetic energy stored in the sun's atmosphere. This energy heats up the solar material to tens of millions of degrees, causing it to emit gamma rays, X-rays, and ultraviolet radiation. Solar flares are classified into 3 categories based on their strength. The smallest are C-class flares, which have minimal impact on Earth and can occur frequently during periods of high solar activity. Then come M-class flares, medium-sized flares that can cause brief radio blackouts at the poles and minor radiation storms that might endanger astronauts. But the most intense type of solar flare is the X-class flare. These flares can trigger planet-wide radio blackouts and long-lasting radiation storms. They are often accompanied by coronal mass ejections or CMEs, which can have significant effects on Earth's magnetosphere and geomagnetic field. Each class is 10 times more powerful than the preceding one, and within each class, there is a finer scale from 1 to 9. For instance, an X5 flare is 5 times more intense than an X1 flare. Recently, on the last day of 2023, the sun emitted a strong solar flare peaking at 4:55 p.m. Eastern Standard Time. This flare was classified as an X5.0 flare. NASA's Solar Dynamics Observatory, which constantly watches the sun, captured an image of this event. This flare is the strongest of solar cycle 25, which began in 2019 and is nearing its peak. It came from sunspot AR 3536, which is turning toward Earth and caused a deep shortwave radio blackout over the Pacific Ocean. This sunspot also triggered a coronal mass ejection, which can take a couple of days to reach Earth and cause geomagnetic storms. These storms can lead to the acceleration of charged particles down Earth's magnetic field lines, resulting in the northern lights. So, while solar flares like the X5.0 event can disrupt Earth's magnetic field, affect satellites, communication equipment, power grids, and astronauts, they also give us the chance to witness the spectacular displays of the aurora. As the sun approaches solar maximum, we can expect more frequent and intense solar flares, coronal mass ejections, and geomagnetic storms, leading to more spectacular displays of the aurora. The sun, it seems, is full of surprises.